Okay. Um, Hello and welcome to this tutorial of irrational function. I mean irrational numbers. Irrational numbers. Um. Okay. I hope you still remember the rational numbers. So let us do a recap. Let us do a recap here of rational numbers. Rational numbers. Okay, rational numbers are numbers which can be written in the form of a over b. So numbers which can be um, let's draw a line here, can be written in the form of a over b, where a and b are integers and b is not equal to 0. These are conditions. So we talk about irrational numbers. Okay, this is a definition of rational numbers, numbers which can be written in the form of a over b, where a and b are integers. We know integers we have negative numbers, 0 and positive, etc. So these are integers. So negative 3 is a rational number because it can be written as negative 3 over 1. This is negative 3 over 1. So this is a rational number. 2 over 3 is a rational number. 7 is a rational number because it can be written as 7 over 1. So these are rational numbers. So okay, this is not our deal today. Our deal today is irrational numbers. Irrational numbers. So irrational numbers. So irrational numbers. Okay, irrational numbers. Okay, let us go ahead as from here and look at root 2, for example. Can we write it in this form? Let's look at root of 2. Okay, what is root of 2? Let us look at pi. Okay, what is the value of pi? Root of 2 is 1.41, etc. It goes that way. Let us look for some more numbers here. So root 2 is 1.41421356 etc. Okay, pi, the value of pi is equal to 3.1415926, etc. So you see from these two numbers here that we cannot write them. In a simple fraction, which is going to give us this, because they don't terminate and they don't have a pattern which can make them to be repeating decimals whatsoever. So these are irrational numbers, numbers which cannot be written as a simple fraction, numbers which we cannot write them in the simple fraction in the form of a over b. They are called the irrational numbers. You have seen that the repeating decimals like 1 over 3 equal to 0, 1 over 3 here, say 1 over 3 equal to 0.3333. It goes forever, which we write as 0.3 dot, which means this 3 here is repeating forever. So the repeating decimals are in the category of rational numbers, but these numbers, decimals which do not have that pattern of repeating, okay, are called the irrational numbers. irrational number. So we simply say that irrational number is a number which cannot be written as a simple fraction. That is a rational number. So you are aware of this now. I gave you this in your first activity, and I wanted you to tell me what are these. I just wanted to see, to know, whether you understand that these numbers do not have a pattern which repeats. These are called non-repeating decimal. Non-repeating and non-ending. They never repeat and they don't end. So it's a number which cannot be written as a form, as a simple fraction. Or you can say it's a number a decimal which never ends and never repeats. Okay, decimal number which one never ends, never ends, and two don't repeat. So it goes like this. Pi moves forever, root of 2 moves forever, root of 3, any root of imperfect numbers which are not perfect, they will never repeat, they go forever. So root 2, root 3, root 5, root 7, root 11, they will never end because they are not perfect. Perfect square, just like 4, 9, or 16, those are perfect number, but other numbers which are not perfect do not end. So simply these are examples of irrational number, and now we understand what is an irrational number. Is a number which cannot be written as a simple fraction, okay, or decimal number which never ends and do not repeat. Okay? These are simple definition of irrational numbers. Okay, we are now looking at some examples on irrational numbers. Identify irrational numbers from the following numbers. Okay, you have to be very clever here and see what are irrational. That's why we did this. We did a recap on irrational numbers. Okay, so this A here, A is A rational or irrational? This is not. This is rational. So this is rational. So it is not irrational. You don't pick it. Okay? So that one is irrational. And how about this one here? This one here, I leave it for you. This is 0.678 repeating. I leave it for you. How about this one? Okay, this one here. I can do this. We do this together. So I did this one, and I'm going to do this one. See, root of 7. What is root of 7? Okay, what is root of 7? So root of 7 from tables or from calculator, you can see it is 2.6457513, etc. So this one here does not terminate. That does not terminate, and it is not a repeating decimal. So this one is irrational. Okay, irrational number. So we say square root of 7 is a rational number. Okay, now you can go for D and E and B. I leave these three for you. You do them. This one here, I didn't do that one. I did this. I didn't do this and this. You do all of these and see if you can identify irrational numbers and the other numbers. Let me add here F. F. Okay, root of 49. Is this rational or irrational? Okay, you do that. And yeah, those are very enough for you. So you do this and we meet on the next tutorial. Thank you.